Hello, in this clip, we'd like to go over the solution to quiz number 10. Please make sure you know how to apply definition of derivative to find derivative functions or derivative at a point. And these questions were assigned to you on homework number 4. And similar questions will show up on your midterm exam, which is just a couple weeks away. All right, so this is week number 5. Our midterm is going to be week number 8. So it's better we get over this as soon as possible. So here I just posted the solution in written form, but I feel like if I can go over this step by step for you, for those of you who did not do so well on the quiz, may benefit. All right, so let's get started. The function we're going to find derivative for would be f of x equals the square root of 1 minus 2x. So we need to find, in order to apply the definition that was given, that we need to figure out what is f of a plus h, right? This is f of x. So when x is replaced by a plus h, everywhere x will be replaced by a plus h. And then if we distribute -2 to a, we get -2a, -2 to h, we get -2h. And f of a, of course, is just directly substituting x by a. And next, we're not going to take limit yet. We're just going to do the substitution. Okay, f of a plus h in place, right? We just got that. And f of a divided by h. And obviously, if we are in a limit setting, we cannot take limit by limit law because that will cause the denominator equals to 0. So we cannot apply limit law. We need to figure out some ways. And obviously, we have radicals here. So we're going to multiply we're going to multiply 1. Anything times 1 stay the same, and we chose the 1 to be the conjugate of the numerator. Let me make the fonts a little bit larger. Okay, so we chose the conjugate of the numerator, which is the first radical adding the second radical. Okay, so we just basically copy this piece and change subtraction to addition. So we have a situation that we can do a minus b times a plus b. Okay, and notice that you have this radical plus the other radical, right? And next, we're going to apply this rule. So we're going to see that. Okay, a minus b times a plus b, that's a squared minus b squared. So this is a squared, right? That's b squared. In the denominator, okay, h multiply the whole of that. Because it's addition of the two, we must insert parentheses here. All right? And the next step, of course, we're going to we're going to simplify the numerator. Okay, this piece, it's root x squared, so it's just 1 minus 2a minus 2h, and that piece is going to be 1 minus 2a. And then we're going to simplify. We're going to simplify that. Subtracting 1 plus 2a. So this is from here, applying negative sign to every term inside the parentheses. So we got that, and reduce it, we could have -2h. We're going to have a -2h. All right, and h reduced, so we're going to have -2 over the whole of the denominator. By this time, we can take limit. So we are going to take limit. When we are taking limit, we can do direct substitution because this will no longer cause 0 denominator. So it's a direct substitution at this point. when we combine terms, right, we have -2 on top. We have in the denominator, we have root of 1 minus 2a plus root 1 minus 2a. That's twice of it. So we have 2 times it. 2 and 2 reduced, we get -1 over the square root of 1 minus 2a. So that was the first question. So please, okay, watch it over. Okay, if you have hard time with these kind of algebraic questions, that means that this is the perfect opportunity for you to work on your algebra, to improve your algebra. You will need these skills in the future chapters. All right, so let's look at the second question. Second question is to find derivative function. So the formula is given. The function we're going to be working with is a rational function. Okay, this rational function. So please continue to work with me with paper, pencil. Okay. So first of all, we're gonna make f of x plus h. F of x plus h. If you line up with f of x, it is just replace everything x by x plus h. Okay. So when we do f of x plus h, everything x will be replaced by x plus h. And then we have the option, you can keep it the way it was. Excuse me. And you can also expand it 2x plus 2h, and just reorganize our term like this. Okay. And you will see soon that why I do this way. Because I wanted to simplify the process and make it easier and cleaner and not to make mistakes so easily. Okay. So anyway, so if you insist to do the expand the whole thing, that's not a problem. But I'm just going to show you a slightly different way. Hopefully, it will also help you to improve your algebra. So we substitute f of x plus h, which is right here. And the other one is 2x plus 1 over x plus 3. So that's f of x, right? So substitute it properly. And next, we're going to reduce this complex fraction. Be careful when you write this. Make sure it has the right alignment. If your alignment is off, it could get you in trouble because you might confuse yourself. So we found the common denominator. So here we see that there's the one denominator. Let me put a space here, right? This is one denominator. There's another denominator. H can be seen as a denominator over 1, but you don't really need to do that, right? Denominator is 1. So we really have 2 denominators to make a common denominator. So, and that's the product of the 2. So we multiply the numerator by the common denominator. We multiply the denominator by the common denominator. That's the next step, right? So we multiply by 1. Anything times 1 stay the same. So we apply that mathematical principle. And next, this step, you can skip this step if you're so much, comfortable with algebra. Otherwise, what I did here is I'm taking the numerator to multiply this piece, and I take the same numerator to multiply that piece. And take this denominator to multiply h. So I got the bottom, which is h times x plus 3 plus h, and the denominator, and there's another x plus 3. So on these, I'm going to simplify. Okay, as you can see, this piece and that piece will reduce. The numerator will be left with, right? After these 2 are gone, makes 1, you'll get 2x plus 1 plus 2h, multiply x plus 3. That's this term. And similarly, x plus 3, this 2x plus 3 will reduce. So we got 2x plus 1 left in parentheses, and x plus 3 plus h. All right, so that's our second step. You can actually go to this step directly. Okay, I did see some of you did that. And next, of course, you can FOIL. You're gonna FOIL all of these. You can FOIL any way you want. You really can FOIL anything you want. On the first, you can, if you FOIL, you're gonna get 6 terms, and this other one, you're gonna get 6 terms. You're gonna get the right answer if you do it right, okay? I, however, wish to show you a different way to look at this, because this is just in an effort to avoid mistake. So what I did, okay, so what I'm doing here, I'm going to treat 2x plus 1 as one entity, okay? So I'm going to show you a little picture just so you can see what I'm doing here, okay? So I basically call this, I'm going to call 2x plus 1 capital A, okay? So that's my capital A, okay? X plus 3, I'm going to call them capital B, okay? So in my, so capital A, so this should be on scratch paper, okay? Capital A is 2x plus 1, is 2x plus 1. Capital B is x plus 3. I kind of simplified the process, okay? So what I'm going to do next is that I'm going to do B times A and B times 2H. Okay, so our next step is I will get A times B plus 2H times capital B. On here, I will do negative A times B, that's a negative AB, and negative A times H. So negative A times H, this is going to be minus. Okay, that is essentially what I got here. Okay, so this piece is A times B plus 2H times x plus 3, because x plus 3 is a capital B. Okay, it's a way to simplify. It's a way to simplify, to keep it nicer and cleaner. This is a capital A times B as well. So you can see from here, we can cancel minus AB and a plus AB are reduced, right? They're reduced. And then we can bring back the H, we can bring back the capital B, because that part is a little too, because this gives 4 terms and this gives another 4 terms. I just want to, keep it simple. Just want to keep it simple. Okay. So that was the perspective. If you wish to know why I do that, you don't have to do that. I just want to make my life a little bit easier. Okay. That's all. And of course, we get to this part, which is over there. Okay. So that was just a little note. I'm going to put it next to it. You don't need to show it to your reader, but in the future, you will see this kind of technique. I will show you these techniques can really help you. Well, if you opt to it, right? It's optional, and because many of you did the FOIL, you did this 6 terms, you dealt with it, you got the right answer, but we also saw people who did not make it. You get messed up. So this way, hopefully, can simplify our life by doing a little bit substitution. All right. So I'm going to put this one over here. Let's see, where do I put it? I'm going to put it here, right? So that's equal, because I don't want this to affect you too much, right? This is just a little note. It is optional besides. Okay, it's optional. But think of, if you're thinking of working simpler, working smarter, and also not make so many mistakes, this would be a way to go for it. Okay, so I'm gonna removing that. I'm gonna put it later just in case anybody wants it. Okay. Okay, so follow that same idea. You can see, so that's what I did. I take a 2x plus 1 as one entity, 2x plus 1 multiply x plus 3, and 2h times x plus 3. I just simplify, I just get two terms. And I take 2x plus 1 as one entity to multiply x plus 3, I got this. And the negative 2x plus 1 times h, I get a minus h times 2x plus 1. So whether you introduce those symbols explicitly or not, my work gets significantly reduced. So this piece, subtracting that piece, we only have these other two terms left. Okay. And then we're gonna, this time we're gonna distribute, right? We distribute 2h times x, that's 2hx, 2h times 3, that's 6h. Negative h times 2x, that's negative 2hx. Negative h times 1 is minus h. And after that, right, after that, 2 times hx, subtracting 2 times hx, that makes 0. 6h minus h, that's 5h. Okay? So by this time, we can finally reduce the h. After h is reduced, we're going to take limit, because we cannot take limit before h in the denominator, right? So now we can, right? We take limit, and the rest will be pretty straightforward. However, be careful. We are substituting h by 0, so we get x plus 3 multiply x plus 3. That x plus 3 multiply x plus 3, that's x plus 3 squared. Okay, so that's all. So I hope that this will help you to go step by step, right? So even if you've done it pretty well, it's a good opportunity for us to practice algebra. Then you say, well, yes, we're going to have lots of derivative laws to apply to take a derivative. Yes, that's true. We may not be using definition to find derivative, but applying derivative rules will also generate complex algebra that we need to know how to work with. So it is to your advantage to practice and regain your algebraic skills as early as possible. All right, thank you for watching.